It was a year of preparation, especially for the reusable space shuttle. Astronomers were able to point an orbiting telescope at stars while aiming and making corrections, much like ground-based observatories. Pioneer spacecraft arrived at Venus and landed on that planet's shrouded surface. The Voyagers continued their journey toward Jupiter and Saturn. With the Department of Energy, NASA built a wind generator for a small New Mexico town. And in aeronautics, a wide range of research projects to improve both general and commercial aviation. If all goes according to schedule, scenes like this, a reusable space shuttle making its final approach to land, will be a common sight beginning next fall. Many of the tests and much of the training to prepare for that historic first flight took place in 1978. 47-year-old John Young, veteran of 2 Gemini and 2 Apollo spaceflights, will be commander for the first manned shuttle mission. Here, he practices making landings in a space shuttle simulator at the Johnson Space Center with Robert Crippen, the 40-year-old astronaut who will fly with Young as pilot. Anticipating the space shuttle's flight schedule in the years ahead, NASA selected 35 new candidate astronauts in 1978 to begin training as shuttle mission specialists and pilots. The 35, including 6 women, were chosen from nearly 8,000 applicants and will be training until mid-1980. Enterprise was flown in its now familiar plane-on-plane berth from California to NASA's Marshall Space Flight Center in Huntsville, Alabama. For the first time, all the major components of the Space Shuttle Transportation System came together for testing. When completely assembled, the shuttle orbiter will sit astride 2 recoverable solid rockets and atop a giant external fuel tank. The entire system was subjected to vibrations similar to those that will occur at launch. At the Thiokol Corporation facility in Utah, a shuttle booster that will produce about 2.65 million pounds of thrust at launch was successfully test-fired again. Each of the space shuttle's 3 main engines that will provide the orbiter with its primary power from launch pad almost to Earth orbit were also successfully tested. Work is continuing on the second shuttle orbiter at the Rockwell plant in California. This is the spacecraft that will actually make the first flight with astronauts Young and Crippen at the controls. Looking farther ahead, Marshall Space Flight Center engineers have been studying problems that astronauts may face during future shuttle missions, and they are doing it underwater. This is one of the few ways that near weightless maneuvers can be practiced here on Earth. 1978 was a very busy year for space science. One of the most ambitious missions involved 2 Pioneer spacecraft that were launched toward a rendezvous and landing on this planet, Venus. Scientists believe that by studying the weather of Venus, they can learn about our weather here on Earth. The Pioneer orbiter spacecraft is programmed to circle Venus every 24 hours, studying the upper fringes of the Venusian atmosphere as it travels along. The second spacecraft, the multiprobe, is made up of a space bus with 4 data-gathering spheres that plunge down simultaneously to different parts of Venus, returning valuable information about its 900-degree surface and carbon dioxide environment. This is a computer representation of the atmosphere of Jupiter. 2 unmanned Voyager spacecraft are en route to Jupiter now. The first Voyager will reach the planet in March 1979, followed by the second spacecraft 4 months later. Then, on to Saturn. At the time of closest encounter, on November 12, 1980, Voyager 1 will have traveled 1.4 billion miles through space. The Voyager missions make it possible for scientists to go back in time and sample the conditions from which the sun and planets, including the Earth, are believed to have formed. IUE, International Ultraviolet Explorer, is a telescope in space which is operated effectively in real time by astronomers on the ground. Visiting astronomers at the Goddard Space Flight Center can have the telescope pointed, decide what data to take, and modify their measurements as they observe. With craft like IUE, scientists can begin thinking in terms of observatories in space as facilities. Also launched in 1978, the second in a series of high-energy astronomy observatories, HEO-2. The 7,000-pound spacecraft carries a large X-ray telescope with 4 major experiments which can be pointed at specific objects to study them in detail. The high-energy explorers are giving astronomers a different view of our universe and helping us to better understand it. The Space Telescope moved through another manufacturing phase this year at the Corning Glass Works in upstate New York and is scheduled for deployment by the shuttle orbiter in 1983. Looking from space with instruments in space, we can see the universe in ways that are impossible from the ground, bringing us closer to even greater discoveries in cosmic astronomy. There was continued and increased emphasis on applications in 1978. Landsat 3, a remote sensing spacecraft, was orbited. Efforts like these over the next decade will try to develop a capability to watch and understand what's happening on the surface of the Earth, land, and water, and to put all that data together in such a way that it can be used as management information for the global environment. Before its so far unexplained short circuit, the first Seasat collected data for 99 days. What it returned during that time were images of sea ice, waves, coastal conditions, and various landforms. It also measured sea surface wind speeds and temperatures. Project scientists expect it will take more than a year and a half to process the data collected by Seasat. This is Beth, a perfectly healthy child of a NASA employee at the Johnson Space Center in Houston, Texas. She is shown here testing out the fit and mobility of an isolation suit that can be used by a youngster with a rare disorder known as severe combined immune deficiency disease. Because of his inability to fight off even the most common germs, 7-year-old David has had to be confined in sterile isolation since birth. The NASA-developed isolation suit now allows David to get out and at least do some of the things normal children enjoy. Ben Abruzzo and Maxie Anderson, 2 of the 3 men that crossed the Atlantic using a helium-filled balloon, stopped by the Goddard Space Flight Center to meet some of the people who monitored their flight with the help of the Nimbus 6 satellite. On their first attempt, the Nimbus 6 beacon made it possible to alert air-sea rescue when they became lost in a heavy storm. So for the second try, Ben Abruzzo said they decided to take along an extra beacon.
On the second flight, because of the fact that we knew that the only link we had with the world on the first flight was the satellite transmitter, we had 2. And again, the information came to us in flight telling us of our course and our position. It confirmed the weather data that our base station had and allowed us to change altitude properly so that we were able to complete the flight successfully. And in fact, on the tail end of it, we changed altitudes and vectored ourselves onto a very close destination proximity of Paris.
Last January, the first large operational wind generator to be used in the United States in several decades began producing electricity. The place? Clayton, New Mexico. Population about 2,900. The project is funded by the Department of Energy and managed by NASA's Lewis Research Center in Cleveland. The 100-foot-high wind generator is capable of producing 200 kilowatts that feed directly into Clayton's utility system, about enough to electrify 60 homes. The research is aimed at improving performance and helping determine the future cost of electric power generated by wind systems. In aeronautics, the emphasis is on basic research and basic technology, preparing the way for future advances in aviation. At the same time, NASA continues to develop technologies to the point where industry can take them up. One of the major research efforts involves using full-scale wind tunnels and other facilities to improve crop dusting aircraft. Studies of how spraying is affected in the wake behind the airplane, handling qualities, fuel efficiency, and overall airplane performance are the goals. See those vertical fins on the wingtips of this small business jet? Those are called winglets, and they were invented by Dr. Richard T. Whitcomb of NASA's Langley Research Center. What the winglets do is reduce the drag on the plane as it moves through the air, saving fuel in the process. Just about any plane can benefit, from the largest jet cargo tankers to small cross-country planes like this one made for the home-built market. Again and again, engineering research pilot Jim Patton forces his single-engine plane into a stall spin. What he and the data-gathering engineers on the ground are trying to do is improve the design for wings and tail sections of airplanes to make them more resistant to stall spins. This type problem accounts for about 30% of crash fatalities in small private airplanes. Combinations of wind tunnels, simulators, radio-controlled model flights, and full-scale tests are used to gather the needed data. This is an experimental XV-15 tilt-rotor aircraft being put through its paces in the 40 by 80-foot wind tunnel at NASA's Ames Research Center. The plane's engines are designed to tilt from vertical to horizontal in mid-flight, making it possible for the craft to take off, hover, and land like a helicopter, and it can cruise at the speed of a fast subsonic airplane. This research is an attempt to develop more economical short-haul intercity transportation. At Ames, they are also flying this experimental jet called the QSRA, meaning Quiet Short-Haul Research Aircraft, a plane that can operate at lower noise levels than most of today's small aircraft, carry the same payload as a 727 jet, and be able to land on a runway as short as 1,500 feet. At the Lewis Research Center, engineers are working to reduce noise and air pollution on aircraft engines that will one day be used for short-haul commuter-type planes, aircraft in the 300 to 500-mile range, which customarily land at smaller airports. To move ahead in research and development and plan the aircraft of 15 to 20 years from now, NASA's Dryden Flight Research Center in California has been test flying the YF-12, an airplane that cruises at 3 times the speed of sound. Being studied are heating, flight stability and control, and structural dynamics, all factors that have great impact on the design and performance of future aircraft. There were 2 anniversaries in 1978 that need to be noted. 75 years ago, Orville and Wilbur Wright made the first successful powered flight in an airplane. It was also just 20 years ago that the space program officially began, an extension of the basic Wright brothers flight. 1978, a year of progress in both aeronautics and space research. This special report brought to you by NASA, the National Aeronautics and Space Administration.